Topic is Rlc Series Circuit. It is also known as acceptor circuit. In this we connect a capacitor, inductor and a resistor of battery of EMF E. In series circuit we know that current is same but voltage not same. But the total sum of voltage across the resistor, capacitor and inductor is equal to source voltage. As the Kirchhoff's second rule says, we see here we connect a capacitor, a resistor and inductor in series with battery. The voltage of supply is equal to voltage of resistor, voltage of inductor and voltage of capacitor. As voltage is different but current is same, that's why we divide the voltage into three parts. Then by applying the Ohm law, V is equal to IR. The value of current, as we know that I is equal to Im sin omega t minus phi dot R plus XL dot Im sin omega t minus phi plus 90. As we know that in inductor the phase difference is 90, and that's why the voltage is lead in the inductor circuit. And same as we put the value of I in case of capacitor, here xc dot Im sin omega t minus phi minus 90, as the difference of phase difference is 90 and voltage is lag in the capacitor circuit, that's why we put here minus 90. Moving on, we take a common from all the equation. When we took Im common, the left behind is R sin omega t minus phi plus XL cos omega t minus phi cos omega t minus phi. Here sin theta plus 90 is equal to cos, that's why we put cos. But in case of capacitor, that is sin minus 90 and it will become minus cos. Go to the next step, we see that Im R sin omega t minus phi, we took a common here XL minus XC from the last two items. Then other step is we put here formula of sin alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta, and also put here formula cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. The equation will become by putting the formula is Im into R sin omega t cos phi minus cos omega t sin phi plus XL minus XC into cos omega t cos phi plus sin omega t sin phi. Those perpendicular is XL minus XC and base is R, and we here calculate the here hypotenuse, that is R square plus XL minus XC square whole under root. Then we find value of sin phi from triangle, that is sin phi is equal to XL minus XC over R square plus XL minus XC square under root, and cos phi is equal to R over R square plus XL minus XC square. Now the equation 1 becomes, put the value of sin phi and cos phi. Now the equation will become XL minus XC cos omega t into R over under root something value of hypotenuse plus sine omega t dot xl minus xc over hypotenuse. Then rearrange the equation. The factor r cos omega t xl minus x cancelled, and the remaining part, that is r square sine omega t over hypotenuse plus sine omega t xl minus xc square over hypotenuse. Then we take common sine omega t and cancel it on the left side of Vm sine omega t. Here is sine omega t cancelled. The Im from the right side divided to left side, that is Vm over Im is equal to r square plus xl minus xc square over hypotenuse. Here we calculate the formula of impedance. Impedance of the circuit is the whole resistance of the circuit, that is denoted by Z, and Z is equal to R square plus XL minus XC square under root. Now here we draw a simple graph of LRC circuit. At resonance frequency, circuit become totally resistive, because at resonance frequency XL and XC become equal in magnitude and cancel out each other. Reactance of an inductor is always opposite to the direction of reactance of capacitor. Take XL is equal to XC because its magnitude is same but in opposite direction. So we calculate here resonance frequency. In place of XL we put here omega L, and in place of XC we put here 1 over omega C. Omega, we know that omega is equal to 2 pi f. Here f is equal to resonance frequency. Rearrange the equation, we get the value of frequency of resonance, or also known as resonance frequency, that is equal to 1 over 2 pi Lc under root. At resonance frequency, those formula is Fr is equal to 1 over 2 pi Lc under root. The voltage and current are in phase because at resonance frequency current is resistive. Here the resistor has totally perpendicular to the capacitor and inductor. Capacitor and inductor are same magnitude but in opposite direction, and those have same magnitude but in opposite direction.